Subscribe to our channel and click on the bell icon so that you don't miss out on our updates and get notified about our new videos.
Good evening, everyone. A very warm welcome to this session. My name is Mohan Silbercity. I am your speaker for today, this session on Data Scientist Road Ahead. First of all, I would like to thank you for taking time out to join this session. I know the World Cup is going on and you all probably sacrificed that and joined this. I'll make sure it will be worth it. Before we get started, I wanted to do a quick check. How many of you have attended the previous webinar on data science, which we conducted probably 2 or 3 weeks back? Has anyone attended that? Just want to make sure I don't repeat some stuff. Okay, most of you looks like, all right. So that is good. So it won't be a repetition. Otherwise, I can, of course, customize it on the fly. But I'm glad that there is no repetition. There will be no repetition, and you're seeing this for the first time. That is great. All right, so let's do a quick introduction. Let me tell you a little bit about myself before we move forward. The webinar, of course, is on Data Scientist Road Ahead. So basically, I will talk about what is data science and what you need to do probably. This is a brief introduction card about me. I graduated from IIT Kharagpur, a BTech from IIT Kharagpur, of course, way back in 1990, so more than 28 years, I guess. Been in the industry for more than 25 years. I'm currently an advisor, consultant, part-time, faculty, if you will, at Manipal ProLearn. And I will speak up louder. Hari says, sir, can you speak a bit louder? I'm speaking up louder, but just want to make sure all the others are also facing some challenge with my voice, or is it okay? I think I kept the mic. Voice is okay. Some of you are saying voice is okay. No problem. Some of you are saying audio is low. I will speak up a little bit. Maybe it may be a little loud for some of the others, but you could probably adjust your volumes. So I hope this is better. I'm speaking a little loud now. Okay. As I was saying, in this more than 25 years of my career, I was in a variety of roles, working for SAP Labs, which is where I spent a large part of my career. But subsequently, I was with IBM. And then I'm also an entrepreneur. I run my own company. I'm also the organizer of Bangalore Artificial Intelligence Meetup Group. In case some of you are from Bangalore, please do join. And I do conduct sessions there almost on a monthly basis. I'm not sure if some of you are already part of it, if you're especially from Bangalore. So that's about me. So I've been involved with analytics and data science and all that for the last machine learning for the last more than 10 years. So that and I'm pretty hands-on in spite of being, that's good to know, Azhar. So please join in the AI meetup group. I think we can catch up. So these are a few ground rules. Make sure your mic is on mute. Of course, from my side, I've already muted everyone, but just in case it gets unmuted, it may be a good idea to mute yourself so that there is no disturbance. Phones, of course, it's a good idea to put it in silent mode, but anyway, your mics are muted, so it will not make any difference. You can, sometimes the webcam gets automatically enabled, so you might want to disable your webcam if something like that happens, primarily for your convenience, because that will eat up into your bandwidth. And please feel free to put in your questions and discussion points in the chat, because I really want to keep this as an interactive session and not just a one way where I'm just giving you Gyan and you're really not interacting. All right. So if there are any questions, feel free. And of course, if there are too many, then I will have to moderate because we'll have to keep time in mind. We will probably have about, it's scheduled for 2 hours, but we will probably have 1 hour, 45 minutes or so. And towards the end, my colleague Amit will be talking a little bit about our ProLearn course, data science course. But yeah, I think we will go up to probably 9:30 or so. This is how the agenda looks. We'll talk about what is data science, and as the name suggests, the topic is all about data science. But I'll also try to keep it a little more interesting by talking about some of the futuristic topics like AI. Of course, this again feeds into data science, it's all part of data science. And then stitch in some of the other topics like big data, and then what is machine learning, deep learning, neural networks. And it is not just slideware. I have interspersed the slides with kind of live demos. I'll also show you an interesting live Twitter sentiment analysis. We will take the Twitter feed of Donald Trump, right? I'm sure you all like Donald Trump's tweets. He's a very interesting character. He tweets almost every few minutes. So we will take his live tweets and do some sentiment analysis on that, which is a part of our text analysis section. But of course, in addition to that, there are quite a few really interesting demos. I'm sure you will enjoy them. Okay, so with that, let's get started with the definition of data science. I will minimize some of these windows so that they don't come in your way. And in case there is any disturbance in between, just feel free to put it in the chat box. I'm keeping the chat box visible to me, very clearly visible to me. So just feel free to ask questions or alert me if there's something going wrong. Okay, so the definition of data science. What is data science? So this is the Wikipedia definition. This has been, of course, evolving. Long back when we talked about data, it was primarily transactional data. When I started my career probably 20 years back, it was mostly transactional data. There was some database in which we were putting all our data, like ERP data. We were creating orders. All of that was stored there. Subsequently, we were doing reporting. So then we used to call data warehouse, and we used to create a separate database where all transactional data from different systems were coming into that data warehouse. And this was primarily used for reporting on a monthly basis or a weekly basis. The CIO wanted a report of the sales, so the guys would create a report and give it to him for that particular meeting. But subsequently, what has happened is, Amit, welcome to the session. I think your webcam is on. If you could please switch it off. Thank you. All right, great. Right, so subsequently now what is happening is there are a lot of other things going on. It is no longer just the CIO or CEO that wants a report once in a quarter or once in a month, but on an ongoing basis, every employee needs to take a decision. And instead of taking a decision based on hunch, which they used to do earlier, they need to now take data-based, right? Don't confuse with database. Data-based decision or informed decision. So that is where this has, data science has now become an all-encompassing, topic which is used by everyone, no longer limited to the top guys. Each and every employee needs to have access to data. So what exactly is data science? Data science is a combination of all you need to do with data so that you can take what is known as an informed decision, right? Instead of taking based on your hunch, you actually look at the data, analyze the data, and then you take a decision. So this is the exact definition of Wikipedia, which means that it actually includes all kinds of activities that you do with the data. I know from a role perspective, this is all combined into a single role today, data scientist, but there are multiple activities that needs to be performed. So a data scientist role is not, it's not a very small role. There are a variety of activities that that involves a data scientist. But of course, all of us cannot be experts in all these areas. But unfortunately, today, all of that is combined into one role known as data scientist. And what are the activities involved here? Starting from gathering data, it could be structured data, like which is in the form of tables and columns, and I will talk about it when we go to the big data section. It could be unstructured data, which is in the form of text on website. So we need to do some maybe web scraping and get all of that data, or use an API, like I will show you the demo with the Twitter live. And then so you get all the data, then storing of this data, and this could be large amounts of data, so you may have to use systems like Hadoop and so on to store the data. Hari, you have a question. I will come to that in just a bit. Let me just finish this definition. And then analyzing all this data in multiple ways. It could be preparing reports, which could be more or less static, but it could be more dynamic, like doing some machine learning activity on this, trying to predict something, or sometimes it could be deep learning as well. And I will talk about what's the difference between machine learning and deep learning, and so on and so forth, right? So that is all of this together is combined into data science. So Hari says, can you say the levels to become data scientist? So yes, there are multiple roles, there are multiple levels. There are requirements of data scientists at entry level, right? People who need to do some of the very basic stuff. Then there are second level where people are doing, for example, application development, machine learning applications, which means that you use the algorithms, you use the APIs, and then you develop some use cases or applications, like how to, let's say, predicting the stock price. That could be an application, or it could be weather related, predicting the temperature. So that is more forecasting type of, but not only that, you may need to develop a model to predict the sales maybe. And so there are a lot of things that you need to do. So that is the second level. A third level is more at a much higher level, which is you are probably actually writing these algorithms. You're developing these algorithms. So that is really at a very super expert level, right? So these are the different levels of data scientist. I hope that answers, Hari, your question. Rajesh says, are data scientists statisticians? I wouldn't say data scientists are statisticians, but statisticians are data scientists, because all data scientists need not be statisticians, because statistics is one part of data science, right? So I hope that clarifies. How machine learning helpful in data science? Oh yes, see, as I said, sure. So Rohit says, how machine learning is helpful in data science? Yeah, so first of all, machine learning is a part of data science. And how is it helpful? I will tell you, I will talk about machine learning in a little bit, how it is different from writing a code. So machine learning is about teaching a machine or a system to learn about something without explicitly writing a code. And I will show you, demonstrate to you how this happens. I will show you a live demo, how I can teach a system, my system, to recognize, let's say, a pen or a duster or a pen holder. I will show you a quick demo of that without writing any code at all. All right. So that is machine learning. And Rohit, if you just hold on, yeah, I will actually show it to demonstrate to you how machine learning relates to data science. Okay, good. Keep the questions coming. I will, as we move along, but we will continue to move on with the slides. So a data scientist, by definition, these are some definitions from some of the sources like Investopedia and so on. as I said, it combines a variety of roles, and especially in the industry today, the data scientist is a very, very broad role. So anything you do with data today is kind of, combined as a data scientist. So it could be, you could be doing a statistical work, you could be doing machine learning work, you could be even doing deep learning work and AI work. All of that comes under a data scientist. Okay. Rajesh says, okay, yes, Rajesh, that will be weather prediction, sales prediction. Yeah, some of the applications. Thank you. All right. So this is another way of looking at data scientists. So who is a data scientist and what kind of skills do data scientists either have or need to have? So these are the different types. So very often, people ask, is mathematics and statistics a prerequisite? So that's what is shown here, as you can see, right? So this is a very interesting diagram from Drew Conway website. So this is how a data scientist looks like. As you can see, there are multiple variety of roles. So it is, not roles, sorry, skills. So on the one hand, there is maths and statistics, but again, as I said, it is not like a mandatory skill. Yes, it will help. Math and statistics will definitely help if you want to do data science. But does it mean that without that you cannot do data science? Not necessarily. As I said, there are a variety of activities or roles that you can do. Yes, Aman, please go ahead. If you have a question, please type in. Okay, I'm making a note of all the questions on my chat window. Do you need to be a programmer? That's another question. Hacking skills are nothing but programming. If so, you need to definitely have some of these skills, but is everything mandatory? Not necessary. Similarly, hacking and programming skills, if you have, definitely you need some programming skills, especially if you want to do machine learning. A little bit of programming skills will be needed, and the more the better. But does it mean that you cannot do any data science activity without programming? Not really, because there are certain activities like data visualization or a few others where probably you don't, there are certain tools available, like for example, Tableau, right? That also comes under data science. Visualization comes under data science. So you really don't have to write any code there. It's pretty much drag and drop, but then of course you need to have a good understanding of the data, right? So then there are people who are domain experts, right? So you need to have, not you in the sense that if you want to become a data scientist, there are some people we need as domain experts. Okay. So these are people like, for example, you're building a data science application or a machine learning application for retail. Now you need somebody who understands the retail process, who has the retail domain knowledge in order to create those models and things like that, right? So that is what is. So if you have all of this, that is like a very dangerous combination. That means you'll be a super duper data scientist who has maths and statistics knowledge, who can do machine learning, who can program, plus who has subject matter expertise. That's like the perfect data scientist. Okay, but if you don't have that, not to worry. So that's the point here. Yes, Aman, please go ahead if you have a question. In case you have a question, you put a comment saying hello sir, but you stop there. Hari says programming skills means full Java or basics. Okay, so I just said programming skills. I didn't mention which language, right? So there are a variety of languages that are used, and again, it is not in depth. Yes, Python, that's correct, Azhar. So Python is a very common programming language, but we can do machine learning or data science with R. We can do, right? R is also a tool and a programming language in a sense, but purely for data science. It is not a generic programming language to build websites and so on. Python is very popular nowadays. So if any one of you has not yet started any programming language and is looking to learn some program, my suggestion is to go for Python. This is becoming a de facto, I would say, a programming language for a variety of things, not only machine learning, data science, but IoT and a lot of others, right? But if you already know some language like Java, that is also okay. All right, so we can use, potentially we can use other languages like Java and so on. But as I said, Python is a becoming very popular in data science, and in fact our course uses R and Python. So it may be a good idea if you want to pick up some of these. I think that will be good. All right, so Hari says, my concern is, do I need Java or not? As I said, Hari, it is not required. Java is not mandatory, but then again, it depends on what exactly, which area you want to focus on. Let's say you want to go towards machine learning and so on, Python would be good. But again, if you already know Java, so this is my take. If you have no programming language knowledge or experience, you start with Python. That would be a good place to start. If you already know Java, learning Python is not a big deal, so nothing to worry at all. Okay, so either ways, if you don't know any of the languages, learning Python will be actually very easy. It's a very easy language. So again, nothing to worry. So it shouldn't become a stumbling block. Okay, so that's not a roadblock. Not knowing a language is not a roadblock. Then Rohit says, do we need to have good hacking skills other than programming? Yes, it helps. As I said, they've shown here. So here hacking is primarily we are talking about. So it is not really, this is actually programming. When they say hacking, that's like kind of a loose term. They don't really mean the real hacking which hackers do, right? Breaking into networks and so on. No, not really. So here hacking means programming skills, little bit of programming skills, kind of what they mean by hacking. Okay. So yes, yeah. So it helps if you have, but as I said, data science is a very vast area. So if you have some of these programming skills, if you can pick up, that is definitely a very nice to have and a very good advantage for you. But again, if there are people who feel that programming is not their cup of tea, there is no reason to give up saying that, okay, data science is not for me. No, not necessarily. There are some other roles where, like, as I said, data visualization or some of these, which you can definitely pursue within data science. Okay. So Aman says, actually, sir, I'm doing my BSc maths and I'll see. So is it absolutely maths is, if you're doing BSc maths, Aman, that's great. Actually, your mathematics will be helpful. So I must say, people keep calling IT field. So it is no longer IT field, doesn't mean just programming. Maths is a basic, what do you say, a major advantage. People with mathematics background, BSc, BSc maths, statistics, and so on will have a major advantage. So you come from this side of the data scientist. Okay, so Aman, absolutely. So this is definitely a place for you to start data science. Okay, so it is not really considered in that sense. This data science or data science is not considered IT in that sense. So it is not like heavy programming and things like that. Okay, so I hope that clarifies. Yeah, so substantive expertise is basically domain knowledge. Okay, Rohit. So this is domain knowledge, as I explained. For example, if you are on retail. Now, again, what we are talking about here is that these are not prerequisites. Okay, these are not prerequisites. These are to become a data scientist. All right, it doesn't mean that you cannot get started. I just want to make sure you all understand this. So these are not like prerequisites. When you become a data scientist, you should be having some of these skills, right? So you should maybe having a mathematics background so that you can understand the algorithms, and you can probably even at a later point write your own algorithms and so on. So you can look under the hood if you have mathematics background. Similarly, if you have a retail or any other domain expertise, that will. So what happens? I'll tell you. In a project, when we say we are doing a data science project, it's not like one person does all of this, right? So we will have a bunch of people as a team. So there are probably 10 people in the project. So there will be 3 people with the mathematics background, 3 people who are really good programmers maybe, and then maybe another 3 people who have the domain expertise, and then maybe a project manager, and so on and so forth. So that's the way it works. So you don't have to have all these skills. Okay, I hope that helps in understanding that. So it is not that a single person needs to have all of these skills. No, not really. As I said, that would be a super duper, a super data scientist, but obviously all of us have our own limitations. So it's impossible to have, have all these skills in one person. Okay. All right. So yeah, keep good questions. Let's keep it coming. So why should you care about data science? I think the primary reason is that there's a huge demand for data scientists throughout the world, and therefore India is no exception. There is a huge demand for data scientists in India as well. So this is the curve. So Indeed.com is a job site. So this is what they publish. This is not ours. It is published by them. So it's slightly dated about, I think, 2016, but I think the trend is still the same. So it is still increasing. And okay, so that's the primary reason why you should care about data science. There's an excellent choice of career. And so that's primarily the reason. So Zain says, if I'm electronic engineer and I'm up to start a career in data science, is it necessary to start learning Java or Python and R is enough? Okay, so I think there was an or perhaps, or R is enough, I think you're saying. Okay, so yes, so if you want to pursue a career in data science, you need to learn at least one language. And as I said, if you don't know any language, then you start with Python. Of course, you can also start with R and then move to Python. Let me tell you why. So Java is not so much used in data science, but there are certain activities which you can still do with Java. So that's why I'm once again telling you, if you already know Java, then learning Python is not an issue, and you can probably use your Java skills in some of the roles. If you don't have any programming experience, then I would say yes, learning a programming language is at least basics. You don't have to get worried that you need to be a super duper programmer, but you need to learn a little bit of the language to at least understand somebody's code. Even if you don't have to write something from scratch, but you need to write some little bit of code or understand some bit of code so that you can reuse. Okay. Now, the way it works from a programming perspective is R is a good place to start because this doesn't involve a lot of programming. So if you don't have any programming background, I would say start with R. So start with R and R Studio. And get to know the concepts of data science, be it statistical techniques or machine learning techniques or any of these. In that sense, R is a very good place to start with, because because you're new to both, right? You're new to data science and you're new to programming. So if you directly start with Python, there may be a little bit of a challenge that first of all, you need to learn Python and then, right? So my suggestion is start with R, but in the long run, you will need some amount of Python. But again, I want to clarify that Python is a very, very easy language. So don't get worried that. So I think who was that? Zain, yeah. So you're an electronics engineer. I think your concern is since you did not do computer science, can you write programming? Can you learn programming? Don't have to worry, Zain. Python is a very easy language. Earlier, it was even taught in schools. So very easy to learn. You should be able to pick up, but yes, a little bit of Python programming and or R is definitely needed. So to that extent, it will be good to learn, unless you want to go for some roles which don't require any programming language at all, like for example data visualization and things like that. Okay, so that is one. A lot of questions, so let me quickly go through them. Azhar says, but I haven't seen any company recruiting freshers at data scientists. I don't think so. There are some companies probably, but these are not a lot. That is true. I'm sure, I don't want to name any company, but you should look around. Azhar, there are companies recruiting freshers as well. Aman says, I heard from some of my elders that online studies only for professionals doing job and have some job experience. Yes and no. So let me put it this way, Aman. Obviously, the best way of learning is when you have your instructor in front of you in a classroom. No doubt about it. So your elders are right. Okay, no doubt about it. But then, what is the second best option? There are situations where you cannot always do that. Maybe because you are either working, so you can't spend your entire day sitting in a classroom, or you are in a different location and you don't have proper classroom based training available. So what is the second best option? Online is definitely the second best option. And today, with the improvement in technologies, online delivery of content has really drastically improved, so which some of the elders may not probably be aware of. So I would say, yes, your elders are right. So if you get a chance, I would say, yes, join a classroom course, and ProLearn offers that as well. We have both classroom as well as online. But if you are for some reason unable to do that, then the second best option is definitely online. I hope that answers your question, Aman. Then Kingston says, I have 12 years of experience in data warehouse development. It will be, yes, absolutely, absolutely. So data warehouse, which means that you're already an expert in handling data, understanding data, you can definitely become a data scientist. Okay, so Aman says, can we face some problems without any experiences? I wouldn't give a blanket no, Aman. But yes, you can always start it. Again, it depends on individuals. So I don't want to paint with a broad brush. I have seen freshers. I've been recruiting and interviewing people. I have seen freshers who are more knowledgeable than experienced people. I'm sorry, with all due respect to experienced people, because these guys have learned along with their regular course. Let's say somebody is doing a BTech, be it in computer science or electronics, they don't teach machine learning and data science in the regular curriculum, right? But these guys went out of their way, learned on their own languages like Python and machine learning and so on. And when we are interviewing, they already know some of this stuff, right? So I wouldn't classify as freshers and experience in that way. But yes, experience means obviously you're more knowledgeable, so you will definitely have an advantage, right? But and freshers, that's a fact that in general, if you're a fresher, getting that break is a little bit of a challenge, but that's where your perseverance and your capabilities come into play. If you put in enough of effort in learning, I think it shouldn't be that difficult. Okay, there are a lot of questions. I'm not able to move forward, but I hope it is interactive and it is helpful, even though I'm not able to cover the slides. Okay, so somebody, I think the name is not very clear, SH. It will be good if you put your full name. Anyway, I'm RF telecom engineer having 4.5 years. Will it be good for me to start a career in data science? Yeah, again, see, it doesn't matter what is your previous background. As I said, it really depends on your ability to learn this stuff and showcase those skills when you're trying to change your job. So it doesn't matter what kind of background. Of course, if you're an engineer already, that's an advantage for you. You're considered as already knowledgeable in mathematics and so on. But otherwise, yeah, there is no real such barrier as such. Yes, Aman, to get a job, I think that's what I was talking about. I hope that is clarified. Then Azhar says, I have experience in QC, so I do this course now. Will it be fruitful for me? Azhar, again, as I said, your previous experience doesn't really matter. If you're keen and if you can do a good job, absolutely. As I said, there is a, if at all, there is a growing area in IT today. Again, IT can be a little misleading. Data science is the growing area. So definitely, QC also uses, by the way, a lot of statistical tools and data science, right? So from that perspective, I would say yes. Okay, I'm sorry. Yes, I think I will need to move on data science and not career exactly. So let's move on. I think let's talk about data science, as somebody has rightly said. We can, of course, the career is very important as well, but we will have to move on. Otherwise, we will lose time. So data science also includes big data, right? And what is big data? Some of you probably are already aware. These 3 V's are used to define big data: volume, velocity, and variety. So volume is a no-brainer. As you all know, data science has become prominent because of the growth in the amount of data that is available or gets generated these days, right? So volume is a no-brainer. There's a large amount of data. So that is first V. Then we have variety. So variety is what earlier we used to talk about when we said data. When we used to say data, it was basically what comes to our mind was a table. Everything in a neatly formatted way with rows and columns, right? Like you all are familiar with Excel sheets. So that is structured data, but increasingly data is coming in a lot of other ways, like for example, text, right? So text is what is known as unstructured data, and we need to be able to handle that as well. And by the way, one of the studies says that 80% of the new data comes in this format, unstructured format, and unstructured includes text, video, and audio as well. Right? So all this is unstructured. That is what is the variety part of it. And then we have velocity part of it, which is basically the rate at which data gets generated. Okay. So, and the rate at which it gets analyzed as well. So that is basically, we very often call it as real time or streaming data. Okay. I think there are some questions from a couple of others. Aman says, if I have to go for the job after my BSc, my whatever. Okay. So Aman, we will park some of these questions around career we'll come back in a little while. But as I said, these are, there are quite a bit of opportunities. So the first thing you need to do is start learning, and there are a lot of opportunities. So I'm sure we will answer that question maybe towards the end. As we move on, if there are any other, so as the focus, we will of course keep on data science, but of course keep coming. Let these questions keep coming. I will park them and maybe answer all of them towards the end so that we save some time. All right, Aman. Okay, so velocity is the other one. So that is about big data. I'm sure many of you have heard about this buzzword, big data, where we use tools like Hadoop and NoSQL databases and so on and so forth. So I'm sure all of you must have heard some of these buzzwords. Then this is the rate at which data is getting generated so this is a interpretation of how much data gets generated in 1 minute over the internet. And you have, as you can see, a lot of it is coming from social media, Facebook, Google, Netflix, YouTube, Twitter, right? Or web chat. I think this is, this is chat, what do you call chat, I think. Yeah, this is what, WhatsApp, sorry. And so on, right? So a lot of it is coming, exactly. IoT is another area, very good. So this is the next slide, Azhar, very good. So we have IoT. Has anyone heard about IoT? What is IoT? I'm sure Azhar has heard about it, and that's why he has mentioned. Anyone else heard about IoT? Internet of Things, yes, very good. Exactly. Yeah. So Internet of Things is basically, so Karthik, I'll come to that. Blockchain is slightly different and a little off data science, but we will come to that. But again, yeah, blockchain also involves data, but as a technology, it is kind of completely different. So in a way, yes and no, right? So is blockchain really today considered part of data science? No, that's a completely different area. But do they use data science? Yes, that we would say yes. Huh? All right, yeah, very good. Most of you know what is IoT. So Internet of Things, where we talk about everything is smart, right? You have smart cities, you have smart energy, you have smart buildings. So what it means is there are a large number of sensors, and these sensors are sending data which needs to be captured, processed, stored, and all that stuff, and then make sense out of it. You use this data, for example, healthcare data coming from a patient, you collect all of this and you try to predict if the patient's condition will become worse, right? That is where you probably apply predictive analytics and maybe machine learning and so on, right? So this is another thing that is keeping on adding data adding data. And this is a study which says that by 2020, which is in about 2 more years, the number of connected devices per person will become almost 7, right? So each of us will be having almost 7 devices. It includes, of course, your laptop, mobile phone, this, that. So as of today, in fact, all of us have, this is, I think, 2017. So we are somewhere here. So we probably have about 4 devices on an average. Okay, so this is how the number of devices is increasing, which again means it is contributing to the increase in data. All right, so what exactly, where are we heading with all of this? I think the ultimate goal seems to be AI, or artificial intelligence. I'm sure some of you would have heard about AI. Have you heard about AI? Which again falls within, yes, right? So artificial intelligence. So let's take a quick look at what AI is, and what all of this leads into is basically artificial intelligence. So anyone recognizes this image? Oh yes, what is it? Some robot? Yes. Anyone else? Chatbot, face emotion, very close, but she has a name. Very good, Anish. You're right, Sophia, exactly. But some of you others are also right. This is a humanoid robot. Yes, Azhar has hit the nail on the head. So yes, that happened on November 4th, 2017. Saudi Arabia gave citizenship to this robot named Sophia. And obviously the women there were not very happy. As some of you are aware, only recently women are allowed to drive. Till then, they were not even allowed to drive. So in such a country, they went ahead and gave a citizenship to this. So this is just an indication, not that it was very significant in any way, but this is just an indication how AI is progressing, how quickly it is progressing. A couple of years back, actually, there was another very significant achievement. An AI by the name AlphaGo defeated a human champion of a game called Go. I know probably many of you are not aware of this game. Even I was not aware till I heard about this event, that there was a game called Go, right? We are all familiar with chess and all that. Yes, Aman. Sophia's favorite actor is Shah Rukh Khan. All right. Yeah, exactly. Good. Azhar, you seem to know that. This is based on, it is a Chinese game, exactly, right? It is really, this is very significant because earlier we did have some similar events. I think some of you may recall, right? So, for example, IBM's Deep Blue defeated Gary Kasparov. But those were rule-based. Chess, for example, is a rule-based game. So if you can program all the moves, you should be able to win it. You just need computer power, right? But in case of Go, so that's a big difference. So there was actually, when Deep Blue did that, it was not learning. There was no learning there. There was programming. Everything was hard-coded, brute force. Okay. Whereas in this particular case, and that is exactly why this becomes very important, this was done using machine learning and deep learning. Deep learning is nothing but a subset of machine learning. So this was done using machine learning, and this was done by this company by the name DeepMind, which was acquired by Google. Okay, so that is when they did this, it was still an independent company, but obviously now it got acquired by Google. So that is another significant achievement, and the reason is this. You see this number? This, you may feel like there are multiple numbers here, but this is a single number, and that is the number of possible legal positions in this game of Go. And again, I don't have enough time, otherwise I would have gone into a little bit of details of explaining the game, but just for very quick thing, it looks similar to what do you call, as the board shows here, it looks similar to chess, but based on like the white and black coins and so on. But that's where the similarity ends. It's completely, the way it is played is completely different. More than rules, it is based on intuition. And that's exactly why this is so very important. So because rules can be coded, you can write the code. Yes, so that is basically what, and that is exactly what they're saying here. So this is not more than the number of atoms in the universe. Okay, so that is the significance of this event. It was able to do this, and it cannot be done writing code. That's where I will show you what we mean by not writing a code, not programming, but learning. So there is a difference. Here are a few more examples of AI. So we have chatbots. I'm sure all of you are familiar and already interacted with chatbots, right? So whether we like it or not, AI is already in a way here. Anyone recognizes this? What is this? Anyone? This? Alexa, very good. Yes, right? So Alexa is a voice, we call it as Amazon Alexa, very good. So all of you are familiar. There are some TV ads as well coming, right? It's a smart speaker, and it is based on voice recognition. Siri is another one. Many of you probably have an iPhone. You must be using Siri. Then these are humanoid robots, as some of you already mentioned earlier. They are already here in many places. In fact, in China, there is a bank which is completely run by AI. It's basically, this kind of robots. And then this is, yes, that is correct, Azhar. So this is by Boston Dynamics. This is a robot which can navigate what is known as a multi-terrain. So it can climb mountains, it can walk on uneven roads, and all that stuff. And I'm sure this one all of you recognize. What is this? This is the Google self-driving car, exactly. Okay. So all these are already, while of course I wouldn't say AI has matured or anything like that, but it has started. So AI is already making inroads. So that's the point here. Now AI is classified into three types. One is what is known as artificial narrow intelligence and artificial general intelligence, and then artificial super intelligence. Now people are worried about this part. While right now we are at this, right, which is basically at a very, very initial stage of AI. But in about maybe 50 to 60 years, it is predicted that we will be at what is known as artificial super intelligence, which means these AI systems will be able to perform multiple activities and much better than we human beings, which is sometimes can be scary. And that's why people like Elon Musk and Stephen Hawking, I'm sure you would have heard about this famous physicist who passed away recently. And also Bill Gates, a lot of these people are worried about this situation, which is also known as singularity, okay, where AI will become much more powerful and much more intelligent than human beings. Of course, there are multiple theories around that. We don't have to worry for now. But yes, so that is the ultimate goal. That is where probably we are heading. Yeah, that is right, Azhar. So people think that AI will control humans, which may be a valid concern if we don't have checks and balances. And that's what a lot of people like Elon Musk are saying, that it's a good thing, but we need to make sure that we have some protocol, how we develop these, and so on and so forth. Okay, so again, a lot of details are not within the scope of this session, so we will have to move on. And so what does AI consist of? These are the various things that AI consists of. And again, all this is also part of data science. So don't feel that, okay, we are digressing from data science. This is all a part of data science as well. Natural language processing, text analytics, and speech to text, and so on and so forth. And where is AI being used in the industry? I think manufacturing industry, definitely. Robots were used earlier. Now there's a big difference between traditional robots and the robots of today. So traditional robots were kind of fixed in one place and they were pretty much doing one activity. But today's robots are much more smarter. They are more mobile. They can move around, perform multiple tasks, and so on. So traditional robots were not really AI enabled. So they were more programmable, right? So we used to, I think, call it as CNC or whatever. So they were programmed, but today's robots are AI enabled, which means they are learning. They are not just programmed, but they learn. And we will see what exactly is learning in just a bit. Then we have other applications are self-driving cars, right? So self-driving car, of course, is not a very simple car. It has multiple paraphernalia along with it. So it will take some time to become mainstream, but a lot of success already. And if it is okay, I think I will just share one video to show you. Has anyone seen how an autonomous car is trained? If all of you have seen, I will skip that video, but if it is of interest, I can show you one video how this training of cars happen. And as you know, Google is no longer the only one. There are other automotive companies like Honda, Toyota. Everybody is now trying out self-driving cars. Tesla, exactly, yeah. So yes, so Uber is not an automotive company, but yes, Uber is deploying self-driving cars or testing them out, yes. So have you seen a video of how this testing is done, how the training is done? Anyone? I know Azhar says yes. Anyone else has seen? Then I can show you. It's pretty interesting to see. Otherwise, I can skip. So Nikhil says no. Anyone else? I'm just doing you want to see? Okay. So, all right. So many of you haven't seen. So let me just show you then for the benefit of those who have not seen. That will also break a little bit of the monotony. So let me stop this and go to my videos. So NVIDIA, by the way, is and kind of now they are become an AI company. So this is a video by them. Let me show you, and then we can talk what exactly is NVIDIA doing and so on. So there is no audio. Don't have to worry if it is faint.
The universal sign for auto.
Is everyone able to see my screen? Just give me a quick check, please. Everyone able to see my screen? All right. Okay. Good. Thank you. I'll minimize the chat. All right, so I hope you enjoyed that. Okay, so let's go back to our slides. Okay, and let me bring back the chat. Just give me one moment. I'll need to get back the chat box as well, so that in case yeah, okay. Thank you. All right. So let me go back to the slides. All right. Okay. Where else AI is being used? Healthcare. There's a lot of research going on. As you all are aware, cancer is a big problem these days. But one good thing, of course, is if it is detected early on, there is a good possibility that the person or the patient will survive. So in the diagnostic space, they are trying to use AI to see if instead of a doctor or a specialist doing the diagnosis, initial screening at least, not the diagnosis, if AI can be used there. I think a lot of work is going on there. Then a lot of other diseases like Alzheimer's and blindness, so that is another area where this work is going on. On the consumer side, home automation. Now, smart homes have been there for quite some time. I'm sure you have heard about it. But they were still, you were using like a notepad, or what do you call that, tablet, right? Tab rather, to control. But today it is AI enabled to the extent of voice control. So you can actually, Alexa also has the feature to connect with some of the home automation systems, and you can switch on the lights or fans or AC by just talking to it, right? So that's the kind of AI enablement that is happening. Incidentally, even in India, there are, I'm hearing a lot of ads in real estate where homes are AI enabled. So these are smart homes. A lot of new homes are smart homes with voice controlled activation and so on. So that is the one in the AI space, in the real estate space. So what is the secret sauce behind AI? It is what is known as deep learning and neural networks. And what is deep learning? Deep learning is a part of machine learning. So now we need to know what is machine learning, right? So let's go and see what is machine learning, and then we will come back. So this is the definition of machine learning. And it is, by the way, not a very new concept. Machine learning was actually initially kind of talked about by Arthur Samuel in 1959. Can you imagine? Right? So it is not a very new concept. However, the issue was that machine learning needs a lot of computation power. So at that time, obviously, there was not enough computation power, so it kind of put on hold. And subsequently, in the late 90s, from when the computation power increased, and the cloud came into play, and so on and so forth. Now, machine learning is becoming very popular, and I think that's the reason. Okay, so what is machine learning? First of all, it is teaching your system or your machine to maybe learn something without explicitly programming. Now, what exactly is this? I will show you in a demo in a little bit. Just hold on. But before that, I would like to mention that this can sometimes be confusing. So this shouldn't be taken as there is no programming at all. No, that doesn't mean that there is no programming at all. And that's why sometimes these questions come as to, okay, you're saying machine learning doesn't involve programming, and then you're saying you need to know Python. What exactly is this, right? So so let me clarify. So machine learning, of course, consists of writing some program. Okay, you need to write some programs. And then it consists of lots of algorithms, and of course, a lot of data. Okay, so these are the three components. Now, what exactly do the programs do when we are saying it is not explicitly programmed? So the programs, what they do is you write a program basically to start the machine learning process, and also to tell maybe the algorithm that, okay, this is where my data is stored. And once you finish, after the training is done, this is where you need to probably store the data or store the results. So that kind of stuff you do, but you don't write a program. For example, now let's say I want to teach my system to recognize an apple. I'm sorry, I'm bad at drawing, but let's say I have an apple and I want to teach my system to recognize an apple. Others say simulate through network. Yeah, correct. So how do I teach my system to recognize an apple? One way of doing it is writing if-else loops, massive if-else loops, saying that, okay, if the object is slightly circular and having a higher diameter on the top and maybe little lower diameter at the bottom, and it has this particular shade. I mean, it is not actually one particular shade of red, right? There can be multiple shades. Every apple doesn't have identical shade of red. So you need to say if this shade or else this shade or else this shade. So how many can you write such conditions? And then the size is not constant. So every apple may have a different size. So can you write so many loops? No. And that exactly is what we mean by explicitly programming. Right? So we cannot do that, and we don't do that in machine learning. We don't write that kind of code saying, okay, if else, and then therefore this is an apple. You cannot do that. So what we do is, so the program is primarily to say that, okay, look, these are the bunch of images of apples, and these are another fruit, maybe banana or an orange, and so on and so forth. And then you tell the system, okay, now you go and learn to recognize an apple or a banana or some other fruit, right? So that is what is meant by learning. So you don't program it, but you just show the system some examples, and then you say you learn. This is typically how we teach children, right? This is how we human beings also learn. By the way, if a person was somewhere, was growing up in some remote jungle, without access to any of any civilization and so on, and if you show him an apple, he will never say it is an apple, because he's never learned that to recognize that, right? He was never taught. But we normal human beings will know it is an apple because we have been told, we have been taught, right? That's the way you teach a child how to recognize an apple. You never tell the child that, okay, apple has this size and shape and shade. No, you just show an apple and first time to the child and say, okay, this is an apple. So next time the child recognizes. Okay, so that is what is meant by not explicitly programming. Okay, so what are the types of machine learning? There are a few types of machine learning: supervised, unsupervised, and reinforcement learning. Supervised learning is when you have, as I said, labeled training data set. So as I said, you will have, for example, all images of multiple images. And this is what I mean by lots of data, right? So obviously, if you cannot write a program, obviously you need to teach. So in order to teach, you need to have sample data. You need to have, so that is what is supervised learning. You have what is known as labeled data. It is nothing but, label is just a fancy word for saying that you have an image and you tell the system that this is an image of an apple. You have another image of banana and you say, okay, this is an image of a banana. That is known as labeling. So that is known as labeled data. So when you have that kind of data, then you can use supervised learning technique to teach your machine about that. But there will be situations where you do not have labeled data. That is where you will use unsupervised learning technique, where the system will try to recognize some patterns, and then it will try to categorize the data into different types. Okay, so that is unsupervised learning. And then we have reinforcement learning, which is, again, this is more towards deep learning, and this is a relatively newer technique actually. And here it is like it picks up with a little bit of existing data, but it is pretty much learning from scratch. So defining this may be a little difficult, but we will probably later on, you will probably learn about this in a little more detail, because explaining that is not very easy in a short session like this. All right, but that is one more. But largely supervised and unsupervised is what we use. Now, while we are at it, before we go into other details of, I will take you through a few examples of supervised learning. But before that, let me demonstrate to you what I mean by learning. Okay, so and not coding, right? So let me take you through a small demo and then we will come back to the slide. So let me end this. And so there is a nice little website for this. I will yeah. So this is the website link. All of you can also actually try this out. Okay, this is a Google experiments, AI experiments. These are really interesting and nice stuff to learn about learning, machine learning. Of course, they say AI, but again, as I said, machine learning is a part of AI. So let me show you one demo here, which is basically this one. And the moment I launch this, the video will get enabled and you will see me, but that I'm not the focus of this, so I will kind of move away so that you can see what exactly I want to show you. Okay, that's me. You're all able to see it? See the screen? See my screen? All right, okay. So let me move away because what I want to show you is how can I train my system to recognize some stuff. And this is again, as you can see, I'm not writing any program. Okay, and all I have is a browser. The learning is happening actually behind the scenes. Google is taking care of that. But this is just to demonstrate how learning happens. Now, let's say what exactly is this demo about? There are these three outputs, okay? So what will happen is based on what is so first thing is I will train my system to recognize three objects. This will be the first one here, this green color, then this purple color, and then this orange color. And if I show this object after training, this picture will get enabled or triggered. When I show this one, this picture will get triggered. And when I show this third object, this picture will get enabled. Okay. And I will do this without writing a single line of code. So let me start with the pen. So I'm showing this pen, okay, and I will say train. So what it is doing is it is capturing a few images of this pen, and it is learning to recognize it. It will recognize it next time I show it, okay. So this is the first object. Then this is like a, what do you call, eraser or a duster or whatever you call it. So I am the second object it is recognizing, and as you can see, I'm not just keeping it still, I'm moving it. So it is actually recognizing the object and not just a picture of it, okay. And the third one is a pen holder, okay. So I will just show this pen holder in a few angles and it will train, okay. So now when I bring this duster, you see here the second one is getting activated. When I bring the pen, okay, the first one is getting activated. Okay, then when I bring the pen holder, third one is getting activated, right? So how is it happening? It is basically, I did not write any code. Okay, here it is. Yeah, okay. I did not write any code, but I just taught my system to learn about this. Of course, behind the scenes, there is a neural network that works on this to train and all that stuff. But that is the point I wanted to show, that I did not have to write any code. And this is how machine learning works. Now, let me just close this tab and show you one more example. Yes, okay. Okay, so let me show you one more example. Another example is about how we can, and this is more like synthesizing. So AI can not only recognize, but it can also synthesize. So I will play some musical notes, just like a piano. I'll play some musical notes and the system will respond to it with some, matching notes. It will not repeat what I did, but it will try to complement it or supplement it, whatever you call it, okay? So let me play some notes and see. Can you hear that? Let me put the microphone closer to the speakers. So the yellow color is the system generated. It is synthesizing. The blue color is what I'm playing. So I'll play some notes and it will respond. Okay. All right. So that's again some kind of training that has been done, and it is not no programming or anything like that. Okay. So that's one quick demo to understand how learning works. So there was no programming per se to do this part. Of course, behind the scenes, as I said, there is certain amount of programming done to train the model and to do the inference and all that. That is a little bit of programming there, but not really to teach or to do the learning part of it. Okay. Now, let me talk a little bit about some of the machine learning, supervised learning concepts like linear regression and where they are used and so on. And then I will show you probably a few quick demos in R, and then we will, I think we will move on to a little bit of neural networks, and then we will move on to the towards the closing part. Okay, so as I said, machine learning, supervised learning is one of the ways in which you have a labeled training set. What do we mean by that? So one of the common ways is linear regression or simple linear regression, which is what I'll show you a little bit of a demo. But supervised learning in general has two types. One is regression and another is classification. So regression is when you have numerical values or continuous values, like for example, the price of a stock or sales value or temperature. So these are continuous values. Okay, they can have continuous values. And then you have classification. Classification has discrete values or classes. So you say this object is an apple, okay, or another object is an orange. But there can't be anything in between, right? So that's what we mean by discrete. So that object can be either an apple or an orange, or it can be a dog or a cat, right? So that's what we mean by discrete. So that's where we use classification, and regression is used when we are talking about continuous values. Okay. So one of the, again, regression can be of multiple types. So linear regression is one of the types, and simple linear regression is the simplest one, which I'm going to demonstrate. But linear regression is all about you have what is known as an dependent variable, which is usually referred as y. And then you have probably multiple independent variables like x1, x2, x3. These are all multiple independent variables, right? And y is dependent on these variables. So you need to come up with a kind of an equation that will kind of approximate for all the given results or values that you already have, and that is what is known as labeled data. Okay, so let's take a few examples. I know initially you may find it a little difficult, but let me take examples. So let's say we have gathered, okay, as labeled data, information about the heights of fathers and children, okay, across the world. Let's say we have collected maybe 1 million records we have about what is the father's height and what is the child's height. So that means you have a data of million rows. Okay. Now you want to use this data to build a model. Okay. So that when now I give you the height of a father, let's say I give you the height saying that this father is 5 feet 10 inches. Now you need to tell me what will be the height of the son or the daughter, right? So that is one example. Very simple example, but I think to just to drive home the point. So that is, how do you do that? This is where you use linear regression, or in this case, actually what is known as simple linear regression, because there is only one variable, which is the independent variable. There is only one independent variable, just X. There is no X1, X2, X3. There is only one X here, only X1, which is the this is the Y. The child's height is Y, and this is your X. So given father's height, you are trying to predict child's height. So father's height is actually X and the child's height is Y. So you need to come up with a model. Now in this case, a model is nothing but an equation of a straight line. Now the problem here is, how difficult is it to come up with the equation of a straight line? How many points do you need to come up with the equation of a straight line? Anybody? All of you, I think this is high school maths. Equation of a straight line. How many points do you need to come up with the equation of a straight line? 2? Yeah, very good, Nikhil. Right? All of you agree that you just need 2 points to come up with the equation of a straight line. Yeah, exactly, right? So a simple equation of a straight line is y is equal to mx plus c. So you need to, only 2 unknowns are there, right? Mx plus c. So m and c are the 2 unknowns. So if you have 2 points, but the problem here is you have 1,000,000 points. That is the problem. How do you come up with an equation of a straight line where you have 1,000,000 points? If you have just 2 points, you can easily come up. When you have 1,000,000 points, how do you come up, right? So that exactly is the problem that is solved by what is known as linear regression, or more specifically, simple linear regression. So simple linear regression is where you have a single independent variable, and it is easy to represent and explain. That's why we use this, but this is applicable to multilinear regression as well. So how exactly is this done? So you need to basically, let me just show you this. So this is, let's say you have your data like this. In order to find, you remember I gave you that example, in order to find that height, what you need is, you need to have some kind of an approximation. You may not be able to do an exact, it may not be exact value, you probably will not be able to find, but the value should not be way off as well, right? So what you need to do is, in this particular case, in linear regression, we try to find an equation, or we try to find a straight line which is most suitable for this data, right? Obviously, you can't send a straight line through all these points, then it will no longer be a straight line. So you will find what is known as a best fit, right? So that is known as simple linear regression. And if you have multiple variables, you come up with what is known as a plane. Now, again, this is a little difficult to put it on slides. So yes, Azhar, that's a very good point. So if you have more than one variable, independent variable, you kind of extend this. Only thing is, it is no longer, you cannot show it or represent it as a two-dimensional a diagram. And that's exactly the point I was trying to make earlier. A simple linear regression is easy to represent in a two-dimensional diagram and explain, but the concept remains the same. If you have multiple, only thing is you need to come up with, it is no longer a straight line, but it is a plane, because the data is in multi-dimension, and the number of variables will also be more. So each of these will have a coefficient. So x1 will have beta 1, x2, if it is there, will have beta 2, x3 will have beta 3. So you need to basically train your model and come up with, so ultimately what is the model? A model has a trained model, basically. A trained model has all these values determined, beta 0, beta 1, and also epsilon, which is basically a random noise or variable. Okay, so if you have multiple, then you need to come up with all those. In this case, there are only two, the slope and intercept. In the other case, if there are multiple variables, you need to find out all of those coefficients. Now, again, as I said, it's not easy to understand this simply from slides. So I have a small demonstration of that as well. Let me just show you that. This is my demonstration. And again, this is a very nice simulation link. I will just paste it here so that you all can play around with it. So here, I'm just trying to demonstrate how linear regression works. Again, we will stick to simple linear regression because that is easy to show it in a diagram. Okay, sorry. I think I was not sending it to all attendees, only to panelists. I'm sorry about that. The previous example also, maybe I will have to resend the Google one link. I'm glad, Azhar, you pointed that out. So this is also the other link. So, all right. Okay, good. So let's say this is a data of height versus shoe size. By the way, in this, there are multiple examples. So I'll just take one which is easily understood. Height versus shoe size is the data that is readily available. This is what is known as labeled data. So we have for the given height of a person, what will be the shoe size? And it goes from 5, 10, 15, and so on. And how do we find the shoe size for, now let's say we have this data already given to us. Now, given the height of a person, let's say this is in inches. Now, let's say I now get the height of a person as 66 inches. Now, how do I find out what could be? Obviously, it will probably not be 100% accurate, but I need to at least be able to some extent, approximately say what will be issue size. So I have to find the best fit for this. All right. So let me try doing manually. So this is a one which what is known as my line. I can say what will be my equation of this line. Y is equal to whatever, x plus c, right? Ax plus b. So I will, let's say, start with my line like this, and manually I'm trying to find the best fit. Okay, let me see how close I will be with respect to actually what the machine will do. This is actually what the machine will also do. Okay, only thing is it will do much faster because it is computing in the background. So I think this is the best I can come up with. And again, you can try out, it is really fun. Now, how do I know whether this is the best fit? We find out from what is known as residuals or the error. Okay, so this value should be minimal. Again, I will probably not have time to go into the mathematics of this, but this is basically how much error as you can see, this line is not passing through all the points. So some points are obviously giving an error, right? So you add up all that errors and then you square each of those because some of them may be negative and some positive. So if you simply add as it is, it might basically become 0 at some point, right? So to avoid that, you square each of those errors and then add them up. That is known as root mean square error or whatever. So this sum is showing that this has to be minimum. Now, if I keep moving, at some point I'll have to say, okay, this is what I can best do manually, right? So this is the best I can get. So I leave it at that. Now we will ask the system to come up with its best fit line. You see here, system has come up. I'm not very far off. The red line is what system has generated. And if you see so the system generated error is slightly less than what I generated. So not bad. Okay, I'm not such a bad data scientist. All right, so this is one example. So this is an example of simple linear regression, how it works. I hope it was helpful, because sometimes people think, okay, how difficult it is to come up with an equation of a straight line. Why so much fuss about simple linear regression? So this is what we mean. Okay. Now let's go back to our slides. What else we have? We have classification. So what is classification? Classification is, as I mentioned, where we have discrete values. So what are some of the examples? Classification can be binary classification or multi-class classification. Some examples of binary classification: email, right? Spam or not spam. Games, win or loss, whether a game, by the way, I think the World Cup is going on. I don't know what's the score, but yeah. So win or loss, right? So that is where you use classification in order to predict maybe whether a particular team will win or lose. That is binary classification. Sales, whether a person or a prospect will buy or not, right? So that's again binary classification, and so on and so forth. I'll not go through each and every one of them. Then we have the multi-class examples where you need to classify your customers into gold, silver, platinum, and so on. Similarly, image recognition, whether a particular image is of a cat or a dog or an elephant, and so on and so forth, right? So this is multi-class classification. And some of the techniques used for classification are logistic regression, and this is primarily very common for binary classification. There are ways in which you can do multi-class as well, but that is like a workaround. And then we have decision trees, which are used for multi-class classification as well. And this is how a decision tree looks. So it starts with one of the columns or features. These are known as features. And each feature we take and then try to determine based on the labeled data. And then we start classifying whether the person has survived or not survived, right? So this is a binary classification. We are still, in this case, we are doing a binary classification. This is a classic, ship, a Titanic ship example, which is available in RStudio as well. Okay, that reminds me, actually, I wanted to show you in RStudio a quick demo of linear regression. Now, Thank you, Kingston. So England leading 2-0. Excellent. Okay, thank you very much. Okay, so let me go into RStudio. I think some of you probably have not used R and RStudio. This may be a good point to show you in RStudio. I wanted to show you linear regression, and before I went ahead with logistic regression. All right. So this is a very, very simple example. And the reason I wanted to do this demo in RStudio is to show you that how easy it is to actually do some machine learning activity in something like an R environment, right? So this is how your RStudio looks. Has anyone seen an RStudio before? Has anyone worked in R? Okay, good. Azhar says yes. Nikhil also says yes. Very good. So some of you have seen it. I think then it must be looking familiar for you. So for those others who have not seen, so this is how an RStudio looks. And it has a lot of capabilities. Yeah, okay. Yogi Jyoti says no. Yeah. So this is how RStudio looks. And as you can see here, the programming doesn't have a lot of overheads. Like for example, in Java, you have to, let's say, import a lot of libraries, and you need to declare the variables beforehand, the type of the variables, and then only you can use them, and so on and so forth. But here it's actually very simple. I just start using a variable without even declaring it anywhere, right? So I'm saying visitors is a variable, and I'm using a bunch of C's for concatenation. So I'm just creating like an array of numbers, and I start using them, right? Number of burgers. So again, this is another variable I've not declared or anything. I'm just starting to use them. So in that sense, the learning curve in case of R is relatively lower compared to any other normal programming language. But again, R is not a regular programming language. It is purely used for the statistical and machine learning and data science activities, right? So you don't normally develop web application with R, right? Okay, so this example, what I'm showing you is a linear regression. I just cooked up some data, and the example here is I have data about number of visitors and based on and how many burgers have been sold. So let's assume that this is the data from a burger joint, right? And for let's say the last 30 days or something, I'm gathering information about how many visitors have visited, and therefore how many burgers have been sold. As you may as well understand, every visitor doesn't buy a burger, right? So there may be a family coming together, friends coming together, and some of them may just come and check out whether they can eat something or not, and they walk out, right, without really buying. So that's the idea here. But there is a certain relation between the number of visitors and the number of burgers that are sold, and therefore that's what we are trying to do. So I'll not go through the code line by line, but let me just quickly run through this code. So I have this data, I'm loading this data. I can also load it from a file, but in this particular case, I'm keeping it simple. And then I'm converting this into a data frame, and I just do some exploratory data analysis. This is known as exploratory data analysis, just checking how my data looks and so on and so forth. Especially if you're importing some data, this is very helpful. Then I can plot my data to see how the data is looking, visualize, right? I'm plotting and visualizing my data. So this is how my data looks. So as you can see, there is certainly a linear relation between these two values. And then I want to train my model. So training my model is as simple as this. I just call an API called LM, right? Linear regression model. And that's about it. I just assign that to a particular variable and done. It is trained now. Of course, the data is very less, so you don't see the computation happening behind the scenes. But if the data was large, you will see one small red color circle here coming up saying that it is computing in the background. It does take, if there is a large amount of data, it does take some time to do the training. And then I can take a look at how my model looks. So this is my slope and intercept. And then I can draw a line corresponding to that particular model that I have got. And I can get the summary of the model. If I want to do some predictions, I can do the predictions as well. I am using the same data to do the predictions, and then I can see whether how much of deviation or how much of error is there, right? So I just wrote a small piece of code to do that. Okay, so this is, again, I don't want to go into a lot of details, but a very simple example of how we can do linear regression, simple linear regression in RStudio. Okay. We will come back. I have one more interesting demo on live tweets of Donald Trump. So we will come back to RStudio in a bit, but let's go back to our slides in the meanwhile. So we talked about supervised learning, we talked about the linear regression, and we talked about decision tree, logistic regression, which is for classification, and so on and so forth. And then we have unsupervised learning. So unsupervised learning, as I mentioned, is where what you use when the data is not labeled. You don't have labeled data. That's where you use unsupervised learning. And unsupervised learning primarily consists of clustering, but there are a few other techniques like association and so on and so forth. So what it does is it kind of measures the, I'll just put it in a slideshow mode. So it basically takes a look at all the patterns and characteristics of all the data that has been provided or the objects that have been provided, and then it kind of puts them together, all similar data it tries to put together. That is known as a cluster. Right. One example I'll give you is, let's say you had data about cricket team, right? And let's assume that the names of the people, or whether they are a batsman or a bowler or an all-rounder, that has not been given in that list. You have an Excel sheet of cricketers and that data, and that Excel sheet has the number of runs. I'll just, let's say I have a sheet like this. I have the number of runs that they have scored, number of wickets that they have taken, number of catches that they have taken, and that's about it. But I really don't know whether they are classified as a batsman or a bowler or an all-rounder. That is not given, for example, right? Now I need to, how do I try to find that out? So that is where, so this is, if this was available, then that would have become label data. Then I could have trained a classification. I would have used classification to train my model, right? But I don't have the data. Therefore, I will use what is known as unsupervised learning, and I will be using what is known as clustering to separate this data. And therefore, what will happen now is it will form clusters, and it will form, put all the people who have scored high runs together, and it will put all the people, because that is one of the characteristics which is common to all of them, right? So it will put all of them that have high wickets together, and then it will create maybe a third cluster who have probably a few runs and a few wickets and maybe a few catches. So these are considered to be maybe all-rounders. I don't know if that's a very good example, but that's the best I could come up with. Cricket is probably something you all associate with, right? So then we know that, okay, these are the people who have a high number of runs, therefore they are batsmen. These are the people who have high number of wickets, therefore they are bowlers, and we can go and tag them accordingly. Okay, so that is one example of clustering. What are some of the use cases? So this is what is done when websites try to scrape data from various places and put the content together, and they need to obviously first do some clustering to say that, okay, these are different categories of the news, maybe if they are gathering news, and then they have to label it saying, okay, this is all is business news, this is technology news, and so on and so forth, right? So these are some of the examples of clustering that we can think of. So one of the most common one, there are different types of clustering, again, or different algorithms that are used, but k-means clustering is by far the most common one. Here the K stands for the number of clusters we want to create. Okay, so k-means clustering is how many clusters. So if I say k-means cluster with k is equal to 3, then it will create 3 clusters like in the previous case. So we need to, typically we provide that manually, but of course there are ways to find out how many, what is the best value of K. There is known as an elbow technique. We will probably not get into the details of that now, but how does this work? So this is a small kind of animation, not really animation, but a visualization of how k-means clustering works. So you have a lot of data, let's say you have all over, okay, you have a lot of data. So what it will do is when you say you create and you, let's say you give k is equal to 3, right? So what it will initially do is it will randomly assign 3 points as what is known as centroids. So C1, C2, randomly, it need not be close to any points, randomly it will assign. Okay, and then it will calculate the distance of each and every data point from each of these centroids. These are known as centroids. That's the first step it will do. And then whichever points are closest to that, each of these centroids, it will assign those points to those centroids as a first step. Okay, then what it will do, it will recalculate the centroid. So let's say these few points have been assigned to this one, and these have been assigned to, let's say, this point, and probably these are assigned, I'm just, my drawings are not very good, so don't worry about it, are assigned to this C3. Then it will actually, for this given data, it will find the centroid, which is like the mean position. So let's say this C1 will move here, and this C2 will probably move here, and this C3 will probably move here. So that is one iteration. Then the next iteration, once again, it will calculate the distances of all the points from each of these centroids. In this process, what may happen is there will be some kind of filtering. So some of the points probably will get assigned to another center. So for example, this may become like this. And this may become, after the first iteration, this may become like this. As I said, my drawings are not very good, but I hope you are able to understand. Okay, Sagnika, I think you will get the recording, no problem. See you, bye. Okay, so, and then, and so on, right? So then maybe again, with the new data points, again the centroid is calculated. It may become, this may become here, this may come here, and this C3 may come here. Okay, and then again the points are reassigned and so on and so forth. So this keeps happening, this iteration keeps happening till these centroids stop changing their position, which means that what is known as convergence. That means the model has converged. Okay, so that is how the k-means clustering will work. I hope that was not that difficult to understand. So this is a kind of, again, visualization. So this is initially randomly, let's say these are the data points, right? I was not able to draw them very well. So these are the kind of screenshots from R. So if we take these three different, actually there are 3 different types of data. So they are marked in green, black, and red. So you can already see that they are in some kind of clusters. So randomly these 3 stars indicate those are the random centroids. Then they get recalculated after assignment, and then they recalculated and so on. So this is the final centroid positions and so on, right? So this is how, I of course had some videos as well, but I think we will avoid for now in the interest of time. But there are some videos with animation which will probably help even better. And we, in our class, we typically show all those animations so that you understand it better. All right, so now that we have learned about machine learning, got some idea about machine learning, we come back to deep learning. Remember, we said what is deep learning, and then we had to go into machine learning because deep learning is a part of machine learning. So what is deep learning? Deep learning is basically a part of machine learning, but it involves mostly unstructured data. And the other thing is it uses neural networks. Okay, so deep learning involves primarily and that is basically the underlying technique of AI. So for example, the computer vision and speech recognition and all these stuff, they use deep learning because the data here is images, video, audio, and all this stuff. And the normal techniques that we use for regular machine learning can be very difficult. I will not say cannot be used, but it can be very difficult to use them for doing these learnings, right? Deep learning. So therefore we use neural networks. So that brings us to the topic of what exactly are neural networks, what is neuron. So let me just go back. I think the order of these slides is slightly disturbed, but nevertheless, I think we can come back here. So neural networks or artificial neural networks are nothing but a bunch of neurons and artificial neurons. And what are neurons? This is basically a simulation of our brain. Artificial neural network is a simulation of our brain. Our brain has billions of neurons that get triggered and activated as long as our brain is working, and they pass the signals. They get the information from our sensing organs like eye, the ear, nose, and so on and so forth, and they process it using neurons, and they're interconnected, by the way. There are billions of neurons interconnected, and therefore they make sense out of it by doing a bunch of activation, non-activation, and so on. So that's very, I know it's not very easy to explain it, but in the short amount of time, that's the easiest, or that's the best we can do. But the point is, neurons are what is there in our brain. And a biological neuron somewhat looks somewhat like this. So this is a representation of an artificial neuron. A biological neuron also somewhat looks like that. It has what is known as a nucleus head with the nucleus, and then it has dendrites, and then and so on and so forth, right? So this is axon and dendrite. So this is basically a simulation of a biological neuron. So there is what is known as, there are inputs, and then there is a processing unit, and then there is an output. And this is a single neuron, and the whole process of training a neuron or artificial neuron is about there are what is known as weights, and then there are what is known as biases. So there is W, and there is a bias for each neuron. So the whole process of training artificial neural network is about coming up with the right values for these weights and biases. That's all about it. Okay. Now, what are these weights and biases? These are a bunch of numbers. So every neuron has a set of weights and one bias. There is only one per neuron, right? So this is how it is represented. So, but how do you come up with the right values for this weights and bias is what the whole neural network training consists of. Okay. So what I'll do is I will show you a little bit of how these neural networks look, and then let me just end this here, and then we will come back to the slides. So there is again a link I will show you. So we use TensorFlow for doing neural networks. Okay, TensorFlow is a library which uses a programming language like Python. Again, you can use multiple other languages, but Python is again the most popular one. So this is a TensorFlow playground, as we call it. You can actually, that link looks a little complicated, but this is a very simple one. It is playground dot. So this part, if you can see, I will try to paste this. That's all you need. If you type that or paste that, it will bring you to this. Okay. So this is a simulation of, again, a neural network. So there are what is known as, there is an input layer, and there are hidden layers, and then there is an output layer. That's what is being represented here. And you can, excuse me, you need to train this, train this neural network to perform either a classification or a regression and so on. So let's say, let me quickly run this demo, and then I will probably explain it in a little more detail. So let's say we can increase the number of layers here. So there are now 3 hidden layers, and per layer, you can actually change the number of neurons. So there will be multiple neurons per layer. So you can add or subtract. And this you will typically, this is what when I talked about the program, right? You write the program. So this is what you basically write in your program. You tell in your program, okay, what should be the architecture of my neural network? That's all. But the actual classification, it happens using this label data. So we have a set of label data here. So this needs to be classified. So you need to build a classifier which will separate this data. So there are 2 classes, orange color and the blue color. So you need to build a classifier. You cannot obviously do with a regular linear regression, or logistic regression will not work here. So you need to come up with a really complicated non-linear model, and that we can do with neural net. So let's say how do we do that? I just do this for this demo. I just run this, and as you can see here, there. So I got the model pretty much. It will continue to run. We will, some of these terms at this point will probably not make a lot of sense, epoch and learning rate and so on, but these are part of the neural network and deep learning course. But what we have seen here is it has now come up with a model which can actually classify this complicated set of data, right? And we can modify, these are what is known as hyperparameters. You can modify these hyperparameters, your learning rate, and what kind of activation function, and so on and so forth, and also the number of layers you want to use. So typically, the higher the layer, the better is the accuracy and better is the performance, but it need not always be. Okay, so we will you will see that later as well. But by and large, that is the thing. So if you have a more complicated neural network with many more layers and with many more neurons in each layer, it typically performs better. Okay. All right. So I think with that, let me quickly show you the sentiment analysis. That is the last thing that I wanted to show you before I hand it over to Amit to talk about our course. This is an exciting demo. I don't want you to miss out. So, all right. So here, what we are going to do is we're going to fetch live Twitter data and perform some sentiment analysis. And I will obviously not take you through line by line here. Number one, we don't have time, and it is also not so easy in such a short session to go line by line. But all I can tell you is that I will be fetching data, real live data from Twitter, and I will be getting data of Donald Trump, and we will do a quick sentiment analysis of his tweets, how many positive, how many negative, and also do a word cloud. What are the more common words that he is talking about? So let me just, without any delay, just run this entire code, and then we will talk about what exactly is happening. Okay, so let me do this. Okay, so you see this red button here that shows that it is processing. In between it is coming up. This red indicates that it is processing. Okay. All right. So we have got the word cloud. This is known as word cloud. This is a visualization of text. And we also got the sentiment. Before I go into the details of the tweets, let us take a quick look at the sentiment. What is this mood today? So pretty positive. I think 50%, I would say. 51% is positive. 27% is negative. And 23% is neutral. So that is the kind of the sentiment of his tweets as of now. And then what are some of the words that he is using, most commonly used? So this is a word cloud. So looks like he's talking a little bit about jobs, and then workers, and looks like there is some Foxconn reference. These are the people who I'm sure some of you are aware in China who actually make the iPhones. And there is something about women, and of course America is there, and so on. Okay, so these are some of the words that are being used in this. But let's go and check what are the tweets that we gathered. So here you see these are the tweets. I hope you're able to see. So it says, big decision will soon be made on our next justice of Supreme Court. I think let me just hover. Yeah, Supreme Court. Okay. Now let's go to the Twitter website and see if really that is what he's talking about. As you can see, this got updated since the last time I checked, right? As I said, he keeps updating his tweets. So yes, so you see here, big decision will soon be made on our next justice Supreme Court, right? So this is really the live data that is coming from Twitter. And the second one is Twitter is getting rid of fake accounts. So let me see if we captured that as well. Yeah, that's the second one. Twitter is getting rid of fake accounts. Okay. And what it has done, it is giving a score for each of these. So this is positive, right? This is a positive tweet and it got a +1. This is a negative tweet. Obviously there are words like fake and all that. So this is negative. So this has -2. And again, the next one is Scandinavia 6 months in tax cuts is already provided something. So let's take the third one. Yes, so this is the one, 6 months in tax cuts. So this is our third tweet, and so on and so forth, right? So as you can see, this is the real live tweets that we are using, and then we are giving a score based on the content, whether it is a positive or negative, and thereby we are creating this a pie chart of overall how many are positive tweets, how many negative tweets, and so on and so forth. Okay. Well, I hope that was helpful in understanding what data science is all about, what are the components of data science, and what kind of demand is there for data scientists and so on. Now, I would like to hand over to Amit to talk a little bit. We have about 5 to 10 minutes to talk about our data science course. Let me stop sharing, and Amit, over to you.
Hey, thanks, Mohan. Thanks for the detailed session.
Sure.
Yeah, just a second. I think.
Yes, we can see your screen now.
Perfect. Okay. So, guys, I'll not take much time over here. I'm going to just take another 5 minutes in terms of, whatever Mohan has spoken so far, or whatever, in last 2 hours, Mohan has given the details about the artificial intelligence, about machine learning, about various programming skills in R and Python and all that. So we at Manipal ProLearn came up with an idea to club all those 3 verticals where a kind of a very solid data scientist can be produced. So do you remember, if I recall back to the earlier session of Mohan today, where he has shown you 3 circles, which was saying you need to be having a good maths, stats, your hacking skills, and your kind of the domain expertise to become a data scientist. Now, keeping that in mind, Manipal had created a kind of a training program on data science, which we call it as a postgraduate diploma in a data science. Now, this program again comes to us in both the variants, as some of you were quite concerned that I'm working, do I need to break my job or take up this training program or something like that. So this program comes to us in both the variants, one in a form of face-to-face classes, which happens at this moment, of course, which happens in Bangalore only. Plus, we also have this training program, delivered to you in a form of an online webinar classes. Okay, now just let me quickly take you through this training program modules and just try to link all those things to what Mohan has, said in last 1.5 hours or so on that part. Now, to start off with, so let's take that bubble, which basically says the hacking skills, where the requirement of programming from a data science perspective, and not of course from a programming or a developer side perspective. I'm not going to talk about that. So from that point of side, if I take, we normally cover both programming in R as well as programming in Python. Now, this programming in R and programming in Python is going to help you in terms of working on all those kinds of data which Mohan has taught you about, in terms of, can I work on any structured data, can I work on an unstructured data, can I work on a kind of semi-structured data. And that's where we're going to be using R and Python in terms of making you more familiar to handle those kind of data sets, and how do we work from a data science point of view on those data sets. Then we also have something known as a data scraping and wrangling. So just to give you a small example, the last demo which Mohan has shown. Cool. So now let me just tell you about this. What is this data wrangling and data scraping? So the last demo which Mohan just showed you on a Twitter, that where we normally scrap the Twitter data and bring into our programming environment of R. Okay. That actually is being done by one of a way of scraping a data known as an API based scraping. So we normally go in terms of how do we extract the data, or how do we take the data not only from a traditional data warehouse like RDBMS, or like might be an Oracle database, or might be an unstructured Mongo database and all that stuff. We also take you through in terms of how do we scrap the data from various social portals like Facebook, Twitter, LinkedIn, YouTube, and all that stuff. So that's where the the data scrapping and wrangling plays a very important role. Now let's go back to that circle in that diagram, Venn diagram, which Mohan was talking about. Okay, that maths and stats. So it's it's one of the major component which actually plays a good amount of role, when it comes in terms of making you guys as a professional data scientist. And that's the reason we have kept a separate module over here known as statistical techniques for data scientists, data science. And that's where we're going to take you through all those key concepts of stats and maths which is required for you, to become a good data scientist as a part of it. Of course, we also work in terms of an exploratory data analysis, like what Mohan in one of his example was saying about that this is an exploratory data analysis when he has shown you a summary of certain thing, that this is a kind of a data, exploratory data analysis we're going to do. So we work a lot on a data, data exploratory analysis and all kind of these things. That's what is the term 1 all about. When we move into the term 2, we hit the road. Okay, so this is where we set up your concepts. This is where we make your basics very, very clear in term 1. And when we hit the road in term 2, we go into an kind of an more practical aspect of data science. And the first thing which comes into picture is, of course, machine learning, which Mohan been talking, from last almost 1.5 hours. So all your machine learning algorithms, in fact, all your key machine learning algorithms, like your linear regression, your logistic regression, your k-means clustering, okay, your random forest, your decision tree, your SVM, and all that stuff is where it get covered. Your time series analysis, which is one of the key analysis which most of the financial organization performs. A lively example is your stock market, predictions or stock market analysis happens to be on a time series data. That's where it all get covered under machine learning. I heard Mohan in between was telling that for those people who want to go into a kind of an domain, a kind of a subdomain in data science where not much of coding is required, a data visualization is a good platform. As a platform on a data visualization, we not only teach you how to do a data visualization in R and Python, we also take you through some of the drag and drop and highly data visualization tools like Tableau, Power BI, and all that stuff. Okay, so that's where the data visualization comes into picture. Then we hit something very important. I think this is just to recollect what Mohan said, the big data technology. So we take you through the entire Hadoop ecosystem in terms of making you familiar with, the Hive, the HBase, the HDFS, and all that stuff, those architectures of Hadoop in terms of how do I handle that big data, how do I process that big data, and how do I basically, do my analytics on that big data, which is coming to me at a very high volume, at a very high velocity, and in a lot of varieties. Okay, so that's where we cover all those concepts under the big data technologies. Then let's come back to that, the third circle in that Venn diagram where it was related to a domain expertise. And that's what Mohan was also saying, that, a domain expertise is a very critical part when a data scientist team work on any of the projects. Okay, so as a part of an elective in our training program, we normally offer you 2 domain expertise or 2 domain knowledges. So we give you our expertise domain knowledge on marketing domain as well as on a finance domain. Of course, they are the elective, so you can choose any one of them. And that's where you're going to start diverting that, okay, I'm going to be a data scientist more focused in a financial sector. I'm going to be a data scientist more focused into a marketing segment and all that stuff. So that's what comes to you as a part of your elective. This is what we make you a kind of an intermediate professional in a data science segment. And when we hit the term 3, that's where we actually go into an advanced side of it. So we start the term 3 with something known as an artificial intelligence. What Mohan was just showing you in the last few minutes of his presentation was all those your deep learning, your neural networks in terms of how do I do the reinforcement learning to my model, how do I make my model learn from his previous iterations and all that stuff. Okay, comes to be a part of your artificial intelligence. That comes to you as a bundle, as a kind of an highly required program in the market, which comes to you in term 3. Okay, then we also go into certain advanced big data techniques in terms of Spark, Scala and all that stuff. Those are really used in the market in terms of doing some real-time analysis, or might be a kind of a more, a data streaming based analysis and all that. So now, again, there is something known as an elective, which is again based on, so one elective is which is based on what you have taken in term 2. So in case if term 2 you have taken as a domain of marketing, then that's where you land up into a marketing analytics. In term 2, if you have taken principle of finance or a finance as one of your domain, in term 3 you end up into something known as a banking analytics. Apart than that, we also give you an opportunity to explore unstructured data. Just to remind you, the text or the sentiment analysis which Mohan shows you, through a Twitter analysis, is a part of an unstructured data analysis. Similarly, there are a lot of other things like sentiment score, your polarity, your topic modeling, your text summarizations, and all that stuff, which is quite popular in the market, and that's what we covered under unstructured data. We also give you an opportunity in terms of taking one more elective, either in a form of a linear programming, which is quite useful in terms of if you wanted to make your career into a manufacturing side, or into might be a process optimization side and all that, and into something known as an RPA, the robotic process automation. This again is an elective part, so you can choose one of them, to make sure that you are going into the right direction. So this is the end of the presentation from my side, and this is just to summarize that whatever Mohan told you in last 2 hours in terms of that what is the future of a data science, or which way the data science is moving. We have tried our best in terms of bundling them together as a part of an full-fledged training program, which could be taken either in an on-campus in our Bangalore campus, or in an off-campus environment through our online learning mode. Right. So that's all from my side, Mohan, and I think we are open in terms of any of your questions or anything you guys wanted to ask further.
Great, thank you, Amit. Yes, so we will probably give a few more minutes in case we are past, of course, the 2-hour mark. We are 8 minutes past that, but again, we started a little late. So in case those of you who are still there, if there are any further questions, we will be able to probably take up a couple of more questions if there are. Otherwise, we will probably end the session. So Karthik says, Amit, you want to take that up?
Yeah, I'll take that up. So Karthik, so I told you this program is available to you in 2 variants. So when I say 2 variants, if I talk about the face-to-face program, which is available to you in a Bangalore campus, that's going to be a 11-month training program, which is divided into 3 terms. So when I say about 3 terms, it's term 1, which is a 3.5 months duration, term 2, which is again a 3.5 month duration, and term 3, which is a 4 months duration. In that last term, which is a 4-month duration, the first 2 terms is basically your classroom studies, and the last 2 terms is completely an industrial project or might be an internship. Okay, whichever the way it goes on that. So it's an 11-month program if you are taking as a residential program, in our campus, which again happens to be. So just let me tell you this: the program which we conduct in our campus again happens to be in 2 ways. Either a residential program where you can be a full-time Monday to Friday, you will be learning things and all that. You can also join it as a part-time training program, which happens to be only on Saturday, Sunday, 9 to 5. Okay, so it happens to be in that way. In case if you wanted to take up this in a form of an online training program, so the one which we deliver in an online training program is a certification program, okay, which is of 9-month duration. Right, so I hope that answers your question, Karthik. Cool. So Kingston said, what kind of a certificate I get after the completion? Is it recognized worldwide? Okay, fair enough. So yes, in case if you are taking a residential program or you are taking a regular training program, which happens to be in our campus in Bangalore, you'll get something known as a PG diploma. That's a postgraduate diploma in data science, which again comes from Manipal Academy of Higher Education, which we we used to call it as Manipal University, but now because of some UGC constraint, we can't name it as Manipal University. So we call it as Manipal Higher Academy of Education. Okay, MAHE. So that 11-month training program is purely a postgraduate diploma. But if I talk about the online mode of it, which is in form of a 9-month training program, that's a kind of a certification program. So we call it as a PGCP, that is a postgraduate certification program in a data science. Of course, since both of them comes from Manipal Academy of Higher Education, it's a well-recognized diploma and a certificate worldwide. Reason being that because Manipal Academy of Higher Education have campuses across the globe. So we have a campus in Dubai, we have a campus in Antigua, we have a campus in Malaysia, we have a campus in Singapore, okay, and all that. So that's the reason it's worldwide recognized on that part. Okay, Mr. Bharat said, I'm a commerce student with 5 years of experience in finance field. I have already registered for a diploma program since I have no background on any programming language. And as I'm hiring companies, recruit people with IT background, did I really make a good choice? Can I make a good career? So I think Mr. Bharat, Mr. Mohan was emphasizing on this thing that, if you don't have any programming background, okay, I won't say that life will be very easy for you in a data science. I will not say that. Okay, life will be a challenge for you, because if you ask, can I become a good data scientist without a complete no programming? So the answer is completely no on that. You have to go through those hurdles in terms of learning programming and all that. Okay, but if your concern is that, will we teach you a programming language right from the scratch? So the answer is yes. We take you right from the scratch, both in Python and R, okay, in terms of making you familiar. How do I do that level of programming which is required to be a good data scientist, or which is required to be a good machine learning model developer or something like that. So we teach you that from the scratch. But yes, you have to be mentally prepared that you cannot skip you cannot skip programming, which is a very, very important part of a data science domain. So if you are ready to take up that challenge, I think you have to go through some rough patches in 11 months. But yes, I'm quite sure if you focus on it dedicatedly, Manipal is there to help you on that part. And I think you're going to come out as a good, data scientist, after the completion of this 11-month training program. Right. So the Karthik says, what is a course fee? I think Karthik, that might not be the right, we both might not be the right people to answer the course fee.
Yes.
Because we both are from the academic background. Okay, so you ask us about the academic thing, but what we do is that definitely we have your details, we have your email IDs and all that stuff, and somebody from our sales team will definitely drop you a mail tomorrow in terms of classifying what is a fee for the residential program, a 11-month diploma program, and what is the fee for our 9-month certification program. So you might have to wait till tomorrow or might be till Monday for somebody to revert you back for that question.
All right, thanks, Amit. Looks like there are no other questions, but all of them were interesting questions. I'm really glad. I hope the session was helpful. We really appreciate once again that all of you, especially those who stayed back till the end, spending time with us, and I hope it was well worth it. Thank you once again and wish you all the best.
Hey, thanks for watching. Do like the video, share it, and also don't forget to subscribe to our channel for more such videos. Check out exclusive coupon codes for our YouTube learners in the description and visit manipalprolearn.com to redeem it.